Hey, welcome back. Here's what we're going to do. We're going to play a game.
Of a lovely lady who was bringing up three very lovely girls. All of them had
Sunny day, sweeping the clouds away. On my
The people are real. The cases are real. The rulings are final. This is Judge Judy.
Okay, enough watching television. People in K-Town are going to get all mad at you. So what are we doing today? Well, you just identified some pretty popular series, television series. We're going to continue that identification with some pretty popular sequences and therefore series later. We're going to look at the arithmetic and the geometric sequences first. Now, first arithmetic, let's just look at that. Okay, you see the word arithmetic in there. Basically, an arithmetic sequence is one in which the same number is added or subtracted from the term to get the next term in the sequence. So basically, you keep adding a number again and again and again. The number you add or subtract is called a common difference. This makes sense. This vocabulary, common, means it's the same for all, and a difference, the difference between the two terms. Here's some rules. All right, so the first term they have to give you, so that's where it says a sub 1 equals a sub 1. But a sub 2 is you take the term before it and you add some difference, common difference d. All right, for the third term, you take the first term and you add that difference twice. For the fourth term, you add that difference 3 times to the first term, so on and so forth. Do you notice a pattern here? Well, here we have 1d. Here we have the second term. For the third term, we have 2d. 4 is 3, 5 is 4, so notice that we have one less multiplication times the difference. Well, that gives us our formula here. To find the nth term of an arithmetic sequence, we basically start with the first term here, and then we add the difference one less than whatever term we want, because you have to account for that first term that you started with. So if you want 20 terms, they give you 1, you need 19 more. That's 20 minus 1. Okay, so first example, are the following arithmetic sequences? Well, let's look. All you have to do is find differences. So what's the difference here? They added 5 plus 5. What's the next difference? Plus 5. What's the next difference? Plus 5. So they started at 3 and they added 5 each time. So because we started a term and we add the same amount every single time, doesn't change, then we say yes, this is an arithmetic sequence. The common difference here is going to be 5. Now, I'm going to take it a step further. It doesn't say. Let's write the explicit formula. So if I want to find the nth term, how can I do that? Well, we start at 3. And that'll give us the first term. And then every term after, we add 5. So we need to add 5 every term after. Now, to find the 20th term, say, then we're going to have to add 5 19 times. So as we said, we're going to have n minus 1. It's always 1 less than the term that you're looking for. That was hypothetical, that 20 thing. Let's look at the next one. So we start at negative 2. What do? We subtract 10. And we keep subtracting 10. And we do that and do that and do that, and it's the same every time. So this is going to be yes. This is an arithmetic sequence with a common difference of negative 10. Easy enough. Let's find the explicit rule. So a sub n is going to equal, we start at negative 2, and we add how much each time? I'm going to take that add away because we don't add. We subtract 10 every time after that. So you see how that's falling into this generalized formula here. All right, look, why don't you try the next two? First, you have to check, is it an arithmetic sequence? And then if so, let's write the explicit formula. Go! Pause the video. Okay, so here's what I got. First one is not an arithmetic sequence because, look, we add 2 and then we add 4 and then it's not the same, so it's no. Second one here, we add 0.5 every time to 14, so yes it is. Common difference is 0.5. The explicit formula, you start at 14 and you add 0.5, and remember it's always 1 less than whatever term you want. That's easy enough. So let's go to example 2. Example 2 says a sub 20 is 70 and a sub 33 is 96, and they want you to find a whole bunch of stuff including the common difference in the 52nd term and the explicit formula. So let's use some logic here. If you go from 20 to 33, how many terms is that? That is 13 terms. All right, we're going to write that down. And when we go from 70 up to 96, how far is that? Well, that's a difference of 26. All right, so then how much? If you have 13 terms, each step must be what? What's the common difference if you have to go up 26 units here? So that would be 26. We went up 13 terms. That's going to be 2. So that's the common difference. All right, we know the common difference. Now let's figure out where we started at. Well, the first term was we don't know, but we know the 20th was 70. So a sub 20 is 70. We're going to use that. A sub 20 is 70 because that means that, what do we have? Well, it was the first term, a sub 1, plus it's the 20th term, so we had to do 19 common differences, right? So what's the common difference? We know that's 2, so it's 19 times 2, and that's going to give us a sub 1 is going to plus 38 will equal a sub 20. Let me go back and do that again because I know that kind of got a little confusing there at the end. So a sub 20 equals 70. They gave that to us. We know the common difference is 2 because we already figured that out. So we know the 20th term was the first term plus 19 common differences. That's what this formula says right here. And so we just figured that out. We get 38, and all of this has to equal 70 because that's what a sub 20 is. So 70 equals a sub 1 plus 38. So a sub 1 must equal 32. And we're done with that one. So now we can write, what did we do? We found the common difference. 52nd term, let's try that. Well, let's skip that for a second because that's always easier after we do the explicit formula. So the explicit formula is going to be a sub n is going to equal, we start at 32 and then we add 2 for every term after the first one. So now we can find the 52nd term. A sub 52 is going to equal 32 plus 2 times 51. 2 times 51 is 102. And we add 32 to that. We get what? 134. And that is the 52nd term. How about that? We know how to do that. Next section right here, we're going to talk about, timeout time. Take a timeout. We're going to watch a little YouTube video. Not television this time. Actually educational. Here we go.
Hallo, I am Carl Friedrich Gauss. Not to exponentiate my own quadratic, but I am considered by many to be the greatest mathematician to have ever lived. I showed promise even from an early age. While attending primary school in the late 1780s, my teacher tried to occupy my unruly class by asking us to add the integers from 1 to 100. I completed the seemingly monumental task in a matter of seconds, much to the dismay of my teacher. So, how did I do it? Suppose we listed the numbers from 1 to 100. Underneath that, we list all the numbers from 100 down to 1, lining up with the numbers above. Once set up in this fashion, we see that each number on the first line added to the number below it on the second line gives us 101. 100 plus 1 equals 101. 99 plus 2 equals 101. 98 plus 3 equals 101, und so weiter. We have 100 such pairs of numbers, so the total of these two sets of numbers is 100 times 101. This, however, gives us twice the amount that we are looking for, since we have added two sets of integers from 1 to 100. So we simply divide the total by 2, yielding an answer of 5050. If we wish to generalize this solution so that we can add any set of numbers, 1 to whatever, we would set up the formula n being the whatever times n plus 1 being 1 more than the whatever, all multiplied by 1/2. Interestingly, since either n or n plus 1 is an even number, we can always divide this product by 2 and come out with an integer. By applying these principles, I revealed my mathematical genius at a very young age, and my exasperated teacher was thwarted in his attempt to calm his class.
Do you see what we did there? Do you see it? So basically you add the first and the last term, multiply by the number of terms, and then you divide by 2, and that'll find the sum of any sequence. This Carl Gauss here did that when he was in elementary school. What have you done lately? Just saying. Hashtag just saying. Find the sum of the first 20 terms of the arithmetic series. Here we go. By the way, we've switched from sequences into series, because remember, series are when you add the terms of a sequence. No biggie. No biggie. But we want the first 20 terms. So first we have to find the 20th term of this series right here. What is the 20th term? Well, now we go back to what we were doing before. So the 20th term would be 2 plus, what's the common difference here? All right, so 4. 4 is the common difference, so it'd be 4 times 19. Okay, so 4 times 19 is 76, and then we started at 2. All of that equals 78. So that's the 20th term. So we need to find that first. Now that we know that the sum of the series up to 20 is going to equal, there are 20 terms, and we find the first term and the last term, we add them together, divide by 2. So we're going to have 2 plus 78 all over 2. So this is going to be 20, or let me just cancel these right now. That'll be 10 if I cancel it with that 2 down there. So we're going to get 10 times 80, or the sum is going to equal 800. That is easy. If we add the first 20 terms of this series, we get 800. Now, let's work it a little differently here. Let's say that the sum is 2,178. So that's weird. The total sum is 2,178, and they want us to find the number of terms, or n. All right, let's do it. Let's write an ugly formula out. So basically, I'm going to look at this formula right here. We know the sum. We don't know what n is. We're going to have to go back and find what the first term is. Well, we know that. That's 2. We know that already. So what do we got here? The total sum, 2178, is going to equal the number of terms. I don't know that. That's n. And the first term, which is 2, plus a sub n. Now, a sub n we don't know. Let's try to figure it out. So a sub n is going to equal 2 plus, now the common difference here is 4. So we have a common difference of 4, and how many times do we add that to get to the nth term? Well, remember, it's always 1 less than whatever term it is, because we start with 2, that's one of the terms, and we have n terms, so the rest of them are 4 more than that, if that makes sense, so n minus 1. So let me just simplify this. So this is 2 plus 4n minus 4, or if fully simplified, 4n minus 2. So that's a sub n. All right, so let's go back to our little formula over here. The total sum is going to equal n times a sub 1 plus a sub n. A sub n we just figured out is 4n minus 2. This is all over 2. I'm using this formula that's right there. All right, so now how can we solve this? Well, what I'm going to do, in the parentheses, the 2's cancel. We're left with a 4n. All right. Now what? So we're going to get 4n squared over 2 equals 2178. I'm going to cancel the 2 there, and then I'm going to divide by 2 and get what here? 1089 equals n squared, or n is going to equal plus or minus 33. Awesome, but you know what? We can't have minus, because if we're talking about series, an infinite number of terms can't be negative, so n here is just going to be positive 33. I'm going to warn you a little bit though. When we get into this part right here, see how the 2's canceled? If it doesn't cancel, you distribute the n, you're going to be left with a quadratic. You're either going to have to, and I'm warning you right now, you're going to have to factor it. I'm trying to look for somewhere to write this. Where are we going to write this? So you're going to either have to factor it, or you're going to have to use the quadratic formula. All right, so there's lots of explanation written out in the answers, but I think you should be okay solving a quadratic, because this is pre-calc, you know what I'm saying? Let's move on. Geometric sequence. A geometric sequence, very similar to arithmetic. The only difference is we're multiplying or dividing, which, remember, division is just, if we multiply by a reciprocal. So basically, you multiply or divide, that's called a geometric sequence, and we don't call it a common difference anymore, we call it a common ratio. So determine if the following sequences are arithmetic, geometric, or neither. So let's find the differences between the two. First thing we'll do, we'll find the differences. We add 1, and then we add 4. Well, because those are different, it's not arithmetic. All right, so let's check to see if it's geometric. That's multiplying. All right, so we'll get rid of that. And what do we do? Times 2. That's the first set. Times ugly number 3. That's 2 and 3. That doesn't work. All right, so it's not geometric. This one is neither. Neither. Nope. Let's look at the next one here. So how do we get from one term to the next in number 5? Well, divide by 3. We're dividing by 3 here. Divide by 3. Divide by 3. Divide by 3. So this is geometric. This is a geometric sequence, and the common ratio is going to equal, now it's what you multiply by, so it's multiplying by a third because you divide by 3. You have to multiply like 81 times what number here? I don't know, equals 27. You divide, you get n equals 27 over 81, which is 1/3 when we reduce it. Or you just remember division is the reciprocal, so if you divide by 3, you're multiplying by 1/3. Common ratio here, 1/3. Last one, what do we got? Times 5, plus 5, plus 5, plus 5. This is arithmetic because we're adding arithmetic. And the common difference is 5. So we're adding 5 each time. So let's go and we'll find the nth term of a geometric sequence. How does that work? Very similar to the other one. You basically start with a term here. That's the first term, a sub 1. And you have a common ratio. It's what you multiply by. And just like with the arithmetic sequence, it's one less because you have that first term. You start with a sub 1. And then the next term is just a sub 1 times r. And then the next term would be a sub 1 times r, and then times r again. So I'm just going to put a squared there. All right, so that's the third term. Notice the exponent is 2. We'll do one more. So a sub 1, and then we'd have r times r times r again. That'll give us r to the third power. That's the fourth term. So basically, this is the generalized formula here. We have a sub n equals a sub 1 times r to the n minus 1. It's always one less. That's the important thing. So let's look at the example. It says here the third term of the geometric series equals 64, and the common ratio is 2. So let's write a rule for the nth term. So a sub n equals, we need a sub 1. We need the first term here. So how are we going to do this? Well, the third term is 64, and the common ratio is 2. So let's work backwards. If we can go back and find the second term you just divide by 2. And that'll give us 32. And then you divide by 2 again, and that'll give us, look, this is the third term right here. 64 is the third, so this is the second. This must be the first term. So we're going to start with 16 times common ratio here we said is 2, and then it'd be to the n minus 1. That is the explicit rule. So they want us to find the ninth term. So a sub 9, ooh, that's tricky. They look the same. A sub 9 equals 16 times 2 to the 8th, because it's one less here, n minus 1. Do we want a real number for that? That would equal 4,096. Easy enough. You just plug it in and you figure it out. Now we're going to get a little tricky. We want to find the sum of a finite geometric series. Finite means that it ends, because we will get to infinite eventually. But finite means you have so many terms and you want to add them all up, and it's geometric. Well, easy enough. Let's find example 8 here. Find the sum of the first 10 terms of this series. Now first, I'm going to look at it. Make sure it's geometric. So we got times 5. Oops. Times 5. Times 5. So yeah, we have a common ratio, or just r, as used in the formula, of 5. And the first term here they give us is a sub 1. So using our formula here, the sum of the first 10 terms is going to equal the first term, which is 1, times 1 minus the common ratio we know is 5 to the n. Now n is the number of terms. We know that's 10. So we plug a 10 in right there. All over 1 minus the common ratio, which is 5. So this is ugly here. This is all going to equal, when you simplify it, you're going to get 9,765,624, and that's going to be negative when you subtract there, and that's all over -4. When you work it all out, we get 2,441,406, and that is the sum of the first 10 terms. Easy enough. Hey, we got one more example to do, and we're all done. Find n such that the sum of n equals 3,906. Well, this is a little bit more tricky. I will give it to you here. So we know that the total sum, I'm going to use this formula right there. So the total sum equals 3,906. And that equals, we don't know what n is, but we know the formula here. Do we know what r is? We do. We know that that's 5. Do we know what the first term is? We do. We know it's a 1. That makes our life easy. So 1 times 1 minus 5 to the n power. We don't know how many terms, but we do know this is the equation, or this is a formula. If we plug it all in, we just need to solve it for n. So the 1 makes things easy. If that was like a 2 or 3, I'd divide both sides. I don't have to worry about that. So now I can also figure out, what do we get? 3,906 is going to equal 1 minus 5 to the n, all over -4. I'm going to multiply 3,906 times 4, and we're going to get 15,000. It's actually a negative 4, both sides here. So negative 15,624. That's going to be equal to 1 minus 5 to the n. All right, subtract 1 from each side. So negative 15,625 equals negative 5 to the n. So now what? I'm going to get rid of that negative because I hate negatives. Multiply both sides by negative 1. So 15,625, that equals 5 to the n. Now, we're going to have to, like here you might be able to say, oh, I'll just put in my calculator, guess and check. But let's take some logs because you love logs. Everybody loves logs. So we take the log of both sides. Now you know how to do that. And what does that do? That brings the n down. So we get n times the log of 5 equals the log of 15,625. Listen, I know you're at a disadvantage because the logarithm unit was so terrible this year. But we divide both sides by the log of 5. And what are we going to get? They cancel out. You get n equals, what do you get? The log of 15,625. So put that in your calculator. 15,625 divided by the log of 5. And guess what you're going to get? Something very pretty. N equal to 6. That is pretty. All right, so it's the 6th term. N equals 6. 6th term. And that's it. That's how you find the sum of a geometric series there. Now, it gets, some of that logarithm stuff might get a little tricky for you, but I have confidence you can work it out because you passed the logarithm unit. We're all set with this section here. Hey, stay off TV. Quit looking at those series. These are important series. I am Miley serious about this. Good luck to you. This is Mr. Kelly Baumholder. Remember, it's nice to be important. More important to be nice.